Okay, well, hello. Today we continue, or we start rather, in this area of statistics probability called random variables. And well, a random variable is simply a function. You recall what a function is, we talked about that last week, that assigns a numerical value to each outcome of the sample space. Okay, we usually denote random variables by uppercase letters. One example here is flipping a coin. It's an experiment. And recall we could have a heads or a tail. Well, if we define x to be the number of heads observed, the sample space, recall of the original experiment is h and t, we're going to have a head or a tail. And possible mappings of x are, well, x is a function. It maps h to, what, 1, and it maps the outcome t to 0. Okay, or more compactly we represent this as x. Capital X is a maps little x. This is a random variable. This here is a realization of the random variable. It's a particular value of it. I'm sorry, I got this backwards. This little s is an outcome from our experiment, and x maps an outcome to little x. This is a realization. Got that backwards. Realization of the random variable. And x lives, the random variable has a sample space. We call, and for this particular random variable x, the sample space is 0 or 1. Now the set of possible outcomes of this random variable is called the support of the random variable. Okay. Now we have two types of random variables. One is the random variable x is what we say countable if it has a countable set of outcomes. We can talk about what it means to be countable. The random variable x is uncountable if it has an uncountable set of outcomes. And a few examples here are number of siblings. That would be, I'm not even thinking about my lecture, I'm watching the video. This is discrete. This is continuous. Okay. Let's see what this looks like.